Hello everyone, welcome to the Physics Chronicles. Today there was SSB exam in our state Odisha. Some of the questions were very much straightforward, like from the nuclear physics there were some questions from beta decay and from the interactions also. Those questions were very straightforward. And other questions are there are some good questions also. So I have some questions, some 7 or 8 questions I am going to solve in this video, and in coming videos almost all the answers you will get, so stay tuned. And without wasting any time, let's go to the first question. The question was, there was a Hamiltonian given. The Hamiltonian was given as p square by 2m minus m gamma x, और पूछ रहा था XH Poisson bracket and a whole Poisson bracket of this one. इसका वैल्यू आपको पूछ रहा था. So let's solve this bracket first. Let's take this one first, XH. Now put the value of H here. You will get p square by 2m minus m omega x Poisson bracket. If you see, this is there is x term here, and the Poisson bracket of x with the function of x, you know, that is 0. So if we open this Poisson bracket, you will get x p square by 2m minus x m omega x, and this value will give you 0, and only this will be non-vanishing. And you know you have to take the derivative of this p square, that will be 2p by 2m of xp, and Poisson bracket of xp, you know, that is 1. So finally you will get the value p by m. This is the value of this Poisson bracket. Now we have to find out the whole Poisson bracket. Now you get the value of this one is p by m. Put this here and find out the final answer. So you will get p by m, p square by 2m minus m gamma x. And here we have a p term, here also we have p term. So ये cancel हो जाएगा. Only this term will give you non-vanishing value. Now let's open this bracket. You will get p by m, p square by 2m Poisson bracket minus p by m, m gamma x. Minus I have taken here. Okay. Now this will be 0, and this will give you, take all the constant outside. This will be m gamma by m and Poisson bracket of px. This is minus 1. Here I am missing one minus sign. This is minus 1. So finally you will get gamma. This is the answer. Right. And let's take the second question. Let me remove this one first. So the second question is, you know, 3 Pauli matrices, Pauli spin matrices, that is sigma x, sigma y, sigma z, and he was asking the product of these 3. If you see the properties of this Pauli spin matrices, you know that sigma x into sigma y is equal to I sigma z. Sigma y into sigma z is equal to I sigma x, and sigma z into sigma x is equal to I sigma y. Similarly, you can simply do this all the product, like if you take the sigma x value in matrix form 2 by 2 matrix and sigma y as a 2 by 2 matrix, you can simply multiply those and you can find the value of this one, right? And similarly, you know sigma x square is equal to sigma y square is equal to sigma z square, and this gives you I. right? Now we will put these properties here. Now let's take sigma x into sigma y here, and this will give you I sigma z, that multiplies with sigma z, and here you will get I sigma z square, and from here you know sigma z square is I, so you can write down I iota into I. Now this is the answer. And another question was for angular momentum, the commutator bracket of angular momentum. He has given, this is the third question, he has given L square as Lx square plus Ly square plus Lz square, and he has asked to find out the commutator bracket of L square Lz. And you know this is a very basic property. The commutator of L square with any component of L gives you 0. If you take this one, or if you take this one, or if you take this one, this all value gives you 0. If you want to calculate, then also you can calculate. Just put the value of L square here, then Lx square plus Ly square plus Lz square, commutator bracket with Lz. So Lz square with Lz, these are same functions, so this will give you 0. Only Lx square and Ly square will contribute. Now let's take Lx square with Lz. Now apply this product rule. Take it as Lx into Lx Lz and find out Lx Lz, then take this to right hand side plus Lx Lz Lx, and you can do simply the commutation of these things, like Lx Lx Lz gives you minus IH cross Ly. Similarly here also, then you will get here you will get two negative terms, and when you take this Ly square with Lz, then you will get two positive terms. Okay, so negative positive will cancel out. You can do all this mathematics, but here I am telling you that the commutation of L square with any component of L will give you 0. This is very basic property. You must have studied this, right? Then let's go to fourth question. So the fourth question was, these questions may not be in sequence as per your question. Okay, so just remember this one and try to match with your question. Just tick mark with your question, right? Your question. So the question was the direction of magnetic field for a long straight wire which carries current. So now let's take a long straight wire, and here the direction of current is upwards. How to know the magnetic field? You know that if you take the thumb in the direction of current, then all the fingers curling around this wire will give you the direction of magnetic field. So let's say, so I have a pen here, right? So the direction of current is upwards, like this. If the current direction is upwards, the magnetic field will be in the direction of these four fingers, right? So this will curl around this wire, you can see, right? So in this direction it will be inwards, and in that direction it will be towards left, and here it will be outwards, like this goes on. So in the options, I think there were four options. One is in the direction of current, that is impossible. So he is saying magnetic field also in the direction of current, that is not right. Radially outward. Radially outward means I have the direction of current here. Radially outward means like this one, here, 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 here. But that is wrong, because we just saw that direction is like this. Okay, not this, not like this, right? So this option is also wrong. Now third is saying along the lines which circles the current. So this is the current, the lines which circles the current, like this circular path. Okay, so like this, like this. Okay, so this is the right answer. So the answer of this question is along lines circling the current. Okay, let me write it down here. Along lines circling the current. Right, so 4 questions are done. Let's take some more questions. So the next question is, So an eigenfunction of an operator d square by dx. This is the 5th question. So the eigenfunction of d square by dx square is e to the power 2x. So this function is an eigenfunction of this operator. So for eigenfunction to satisfy the eigenfunction condition, you know, if we have an operator A operating on a wave function psi, then you will get some eigenvalue lambda, and this psi remains as it is. So here it is saying that the operator is d square by dx square, and the eigenfunction is this one. Okay, so he is asking for the eigenvalue. So you just have to operate this operator on this eigenfunction. So by operating, you can write down d square by dx square of e to the power 2x is equal to, let's take first derivative. After first derivative, you will get d by dx of d by dx e to the power 2x. This will give you d by dx of 2 e to the power 2x. The differentiation of e to the power 2x is e to the power 2x, and again we have to take the differentiation of 2x. This will give you 2. Now again differentiating, you will get 2 is constant, let's take outside. So differentiation of this one will give you 2 e to the power 2x. So this is 4 e to the power 2x. You can see here, we have taken the operator here, we have taken the eigenfunction here. The function remains as it is, and we will find the value here 4. So answer will be 4. Right? And 6th question is, I am telling it fast because धीरे धीरे बोलूंगा तो बहुत ही लेंथी हो जाएगा वीडियो. तो so sixth question was, there are two vectors. One is A, that is equal to 3i cap minus 3j cap plus k cap, and another vector was given as B is equal to 4i cap plus 9j cap plus 2k cap, and he is asking for the cross product of these two vectors. You know, the cross product is written as I j k 3 minus 3 1 4 9 2. This is the formula for cross product between two vectors. If you calculate this one, then I, and here take this matrix, this is minus 3 into 2 is minus 6 minus 9, and then minus j cap into this one, 3 into 2 6 minus 4 into 1 4, and lastly plus k cap, this matrix 9 into 3 27 minus of minus 12, so this becomes 12. So finally you will get the answer minus 15 I cap minus 2 j cap plus 39 k cap. This is the answer. Right? So the 7th question is, asking for the number of atoms per unit cell for FCC structure. If you remember the FCC structure, Then there are atoms at each corners and at each center of the face. Let me draw the figure here. If you see, this is the 7th question. If you see, the structure is something like this. The structure is something like this, and the atoms are at each corner. One, two, three, four, five, six, seven, eight. Yeah, and at the center of each face, this is one face, this is second face, this is third face, this is fourth face, this is the back side face, and this is the front side face. And if you calculate the number of atoms, then you can write down number of atoms will be equal to, so each corner atom will contribute 1 by 8. Okay, so then we can write down 1 by 8 into, there are 8 atoms at the corner, plus each atom at the center of face will contribute 1 by 2 to one FCC atom. So we can write down 1 by 2 into, there are 6 FCC atoms. Okay, so into 6. So you will get here 1 plus 3 is equal to 4. 4 is the answer. Okay, and the last question in this video is, okay, now he is asking, he has given 4 options, and he is asking for which operator is Hermitian. Okay, so first option is d by dx. Let me tell you some fundamental things. If you take I, then this is not Hermitian, because if you take the complex conjugate, then this will give you minus I, or yeah, so this one. If you take the Hermitian, this will give you minus I, and d by dx is also, if you take its Hermitian, this will also give you minus d by dx. So both are anti-Hermitian, right? Then if you take the in one option, this was given d by dx, so this will be anti-Hermitian, so this is not Hermitian. And in the second option, it is given minus I d by dx. If you take its Hermitian, then minus I will give you plus I, and d by dx will give you minus d by dx. So if you see, yeah, so this will be I into minus d by dx. So we can write down minus I d by dx. So this will be Hermitian. And other 2 options, if you see, there is one I d square by dx square and minus I d square by dx square. So these are also will be anti-Hermitian. Because if you take I d square by dx square, then d square by dx square is Hermitian, but I is not Hermitian. Okay, so the product of those two will give you anti-Hermitian, right? So we have solved 7 questions, and in coming 3 or 4 days I will be uploading more videos. So almost all the questions will be solved in my channel. Okay, so stay tuned. Bye bye. See you in the next lecture.